Okay.
No.
No. Okay. So, okay, let's get started with Hibernate. Why are we looking at Hibernate? The reason being, till yesterday we were like looking at JDBC, which is Java Database Connectivity, and we looked at some APIs. So that being fundamental, Hibernate is like a framework. What is a framework? It's like a set of classes and interfaces that are being part of a jar file. Okay, this helps us in making our job easier. Okay, anytime when we are adapting to a framework rather than the regular APIs, the reason why we do that is if it is making our life job easier. Okay, and if both in terms of development and also performance wise, if it is making our job easier, then only we move to that framework. Same is the case with if you think about it, like JSP and servlet. Yeah, everything started with that in web tier as well. If you look at n-tier architecture on the web tier as well, like we can just deal with JSP and servlets, but there is more top of it, like filters and all that. Instead of you writing on your own, there are like various frameworks that helps you write interceptors. Just tell what you want to do. They give you some boilerplate code. So in that sense, we move towards framework, because when we are working in the industry, we want to make our job easier in development and also in terms of performance. And these are derived from various design patterns. That means experts spent their time, and based on their expertise, they started writing these frameworks. So that's why we adapt to that. Like if you heard about Spring or Hibernate, why they became famous? Because they address a bunch of issues that industry is facing with, and they made the job easier, revolutionized the JDBC layer. That's like if you look at this entire architecture: presentation, service, and JDBC, right? That means you have some service classes, you have a UI, and where JDBC is nothing but talking to the database. That's the tier. Okay, when you're talking about n tier, that's these are like multiple tiers in the application. That means UI, and then service layer. That means on the server side, you guys all become server side developers once you learn Java EE. So that server side stuff, and that talks to the database. That means when you click on Amazon, you put an order. That's like a UI where you put an order. Behind the scenes, some code executes and it generates an order, and it uses database or something to actually persist your order number and all the details. So that's the n-tier architecture. So we dealt with JDBC, which is in green here in this slide, n-tier architecture slide, if you see. And now on top of that JDBC, there is a layer called persistence. Persistence means storage. These Hibernate or IBATIS or any of these frameworks called object relational mapping frameworks sit on top of the JDBC. That means JDBC still exists, but on top of it, they made it in such a way that it is easy for us to access it, and easy for us to save the data and all that stuff. Okay, so the reason why we are using this Hibernate framework, because it makes our job easier compared to JDBC, and it sits on top of JDBC, and it gives us a bunch of more utilities around it, and that's why it became like adapted in the industry. First, Hibernate came into existence, and Hibernate became popular. Then Sun Microsystem or Oracle actually looked at it, and they saw, oh, it's pretty good, and they adapted it onto their Java EE stack called JPA, Java Persistence API. Okay, so that means prior to Java EE5, okay, prior to Java EE5, there is no concept called JPA in Java EE. Okay, Java Persistence API doesn't exist pre Java EE5. They looked at Hibernate, which became so popular before even Java EE5 came into existence, and they saw all good things about it and adapted it into Java EE5 as Java Persistence API. Okay, so that means you can have an application which has a presentation tier, service tier, and Java EE5 can talk about this persistence layer can have JPA, and underneath that there can be a persistence provider like Hibernate or iBatis or TopLink, Oracle TopLink, or something else. So these are all the persistence APIs. Okay, so that means what Oracle did was, okay, fine. These are all various persistence providers that exist in the off the shelf. Why do we say off the shelf if you compare with Java EE? Because these are all outside Java EE, right? So that's why these are like all off the shelf components or frameworks, and they looked at those and adapted it onto Java E5 specification. Okay, you use whatever persistence API that you want, but these are the generic things that we are giving you. Okay, and underneath the generic one you can use any of the persistence provider. That means they generalized it. What they did in Java E5, they looked at all these persistence APIs that are available on the market, and they made it generalized. Okay, if you want to use JPA, use it as JPA. So underneath JPA you can use any of the other frameworks that you want, but JPA will be a standard. Okay, so that's how JPA came into existence. Okay, there are minor differences. People may not use JPA, but they can directly use Hibernate and all that stuff. But I am giving you a context, okay, how JPA came into existence and how Hibernate is, and what is Hibernate. Okay, so now we know why we needed persistence API, and in the coming slides we'll talk about what is Hibernate and all that. Okay, let's look at the slides right now. So application is made up of layers or tiers. Each layer encapsulates specific responsibilities. That means a presentation tier or layer talks about only UI, like flashy UI. If you want to change just the UI, you can just modify it. Okay? Or if you want to just change the server side code, you can just change the server side code. And this persistence or JDBC layer is separate because today you may be using Oracle, tomorrow you may upgrade to some other, or today you're using a cheaper version of MySQL like Community Edition, and tomorrow your business grew and you may go to Siebel or Oracle or something else, right? So these are all can be easily modifiable. So that's why we put it in various layers. Okay, so each layer is independent of the other one, and each layer is responsible for certain tasks. That's when we use this n-tier architecture. So in this n-tier architecture, each layer has its own responsibility. And idea is whatever you change should be agnostic to the other layer. So that way it is like transparent to them. Okay. Then common tiers, presentation tier, view in model and view controller. That's a design pattern, famous design pattern, or we can say it as like architectural pattern, which is called model, view, and controller. What is model? Anything that talks about data tier, or if you look at our training database, student is a model object. That means we talk to database to get the student object or save the student object. That's like a model. Anything that is like a data tier is called a model. View, anything related to presentation is called a view. And control is nothing but any of the server side code. That means on click of a sign up button in Yahoo, it shows a form, and once you fill up the form and you submit it, something is happening on the server side, right? To save the data and all that. So all that is called service layer. Okay. So here is the thing. So presentation tier, view, model view controller, responsible for displaying data, no business logic. So you want to make it lightweight. And service layer is called responsible for business logic. Okay. And persistence layer responsible for storing or retrieving data. That means all our JDBC code that you saw can all be considered in terms of persistence or uh, data tier. Okay, let's move forward. Okay. So now that brings in an interesting concept called like uh, all these classes that actually talk to database are called DAO. DAO is nothing but data access object, which is a design pattern. That means you want to go through this DAO to get the data, to save the data, to update the data or delete the data. These are famous called CRUD operations. Okay, so ultimately, any business operation that you do, like place an order, update an order, delete an order, cancel an order, all these operations ultimately boil down to these operations on the database. Okay, uh, and why DAO is famous is because you write this DAO layer in such a way it is applicable to any database that you move towards. Okay, that means if you have to change anything to the database or anything related to data access layer, you are going to change this DAO class. That's all. Okay, so if you just change it, that's it, you're good. Or if that means all the changes, anything related to data access is all in one place, so you can just modify it or update it and stuff like that. Okay, so that's why data access object pattern is important, and why we are talking about it here, because um, JDBC and persistence layer that we saw in our previous slide, all those are nothing but they follow data access object pattern, design pattern. This is one of the important interview questions. People may ask you, what is a DAO? How many DAOs do you have in your previous project and all that stuff? Okay, so what is DAO? Don't get scared. It's like data access object pattern, and anything like all your like in our previous examples, get student, save student, update student are all part of that DAO class, where you write your SQL query to save the data or get the data and all that stuff. Okay, nobody else knows anything about SQL. Any nobody else meaning no other layer in the application will know what is SQL. So what you're going to do, you're going to talk to the database. Any SQL error that happens, you catch that and wrap it into some business exception. That means service layer only knows all the business related validations, right? So you catch that, you convert it into business exception, and send it to business layer. And business layer in terms of it converts it into user displayable message and shows it to the user. Okay, so that means we should like in any application that you must have seen so far, you will not see SQL exception unless it is like some Indian website where we don't manage it properly. Like professional websites, what we do, we just don't show SQL exceptions or something to the user, because user will be like, oh, what is this happening? These guys are like not very good, right? So that's how like we manage DAO in such a way. Any database exceptions are all being consumed, and we catch those and we convert it into business exception and throw it. Okay, so all I'm talking about is DAO layer is like one place where your data access related stuff will all be there. Any project will have a DAO. Okay, so if you were to understand the code base that already exists, also you can look at a DAO. Then implementing a business logic. Then service layer is like very thin layer, and where you may have some business logic in there. And domain objects are nothing but, if you look at our training database, student object is a domain object. Okay, fine. So there are like various design approaches, like service layer contains all the business logic, complex object oriented model, or thin service layer. So these are like various approaches that you can use. We don't say like one of them is good and one of them is bad and all that stuff, but all we are going to see is in these approaches how the code looks like. If you say service layer contains all the business logic, service layer communicates directly to data access layer. Okay, no object model. Data access layer returns the data transfer objects. That means any data that gets transferred between presentation tier to service tier and service tier to data tier that we saw in our previous n tier architecture, the communication between them is all through DTOs. And this is a old approach. Like when we were coding in probably 2007, 5 or 8, we used to talk about all these DTOs a lot. And now it may be considered as a little bit traditional, because you will have a bunch of duplicate code in your application. Like if you are using Hibernate, anything that is mapping to a table will be an object, and again you're converting something into DTO, which is like kind of traditional. Few people talk about it, but let's see. So requires more low-level code to persist transfer objects to data. Okay, and there is also something called, like, this is the procedural approach. Any interaction between presentation layer and service layer, or service layer and persistence layer, is all through DTO, which is again a beam. Okay, these are all various names in the design patterns. So DTO, data transfer object, that means you got a student object from database. You don't want to expose student object as it is. You want to expose it as some entity, some domain object where entire company knows about it, and you convert it into, like, you grab each and every property from student and set it to a DTO, and then send it back to server side. That means like a student DTO or something, but all the properties remain the same. And then service layer uses that, does some operations, and sends it back to presentation tier as student DTO. That means anything that happens in the database tier is agnostic to presentation tier. Like, they don't know anything about like what columns you have and all that stuff. They just know only the beam. Okay, so what we are talking about here is, like, if you don't use Hibernate, you just get the student object and you convert it to a student DTO and send it back to UI. Okay, there is nothing like a concrete domain object there from the database. It is just the DTO, which probably universally known in the company there. Okay, then object-oriented approach, rich object-oriented model, like, it may be like result in more maintainable code. Like, we deal with all objects, right? All these Hibernate, uh, um, top link or JDO, all these are nothing but, actually, JDO is some framework, probably Java Data Objects or something. Um, it's a mapper framework. Okay, object relational mapping. We'll talk about what object relational mapping is. So that's one approach, wherein anything that is in the database table is represented as Java object here, and then we can send the same object here. There is no concept of DTO in this object oriented approach. This may be a little bit different than what you thought about Hibernate, but we'll go to details in, like, probably 2 slides. Okay, just bear with it. So,
Thin service layer, what is that?
say that again.
Thin service layer.
Thin service layer meaning you are making it lightweight, not like heavyweight. Lightweight meaning not complex business logic in the service layer. You want to make it like uh, lightweight. Like any database operation, you are just delegating. That means, okay, you got a request to create a student. So what you do, you need what all the parameters that you want for creating an student, and you just create the student object and delegate it to DAO to actually create the operations. Like, previously, everything that you do, like any operation that you do, is part of service. There is no concept called DAO, data access object. So that's when service is nothing but heavyweight. Okay, but here we removed an operation called database access from service layer. All the service layer will have is business logic, how to create, check for few business validations, and return. So that way it became like a thin layer. That means it has nothing to do with the database. It has nothing to do with what the UI is. All it knows is all your business logic, all your Java code resides in there. Like, oh, some validation or some check, some business method. Oh, I just need to read a file, or I just need to write to a file, and stuff like that. It's just targeted and lightweight because it's not dealing with anything on the UI or anything on the database. All it is doing is like a delegation thing. Okay, please create a student object. Created a student object and passed it to the downstream layer called DAO layer. And whether it creates it or not, if it creates it, it will return that. If it doesn't create it, it will return an error message that is being written by the DAO layer. So previously, everything is done by them. That's why it is a little bit cumbersome. Making sense?
Yes.
Okay. So let's see.
Is that model we are going to use nowadays?
Say that one more time.
Is object-oriented approach, are we using this model nowadays?
Yeah, we are using Hibernate nowadays. Yeah. Like even now we are moving towards not using Hibernate also in some instances. Like if you go deep, like initial days, Hibernate is like pretty good, and a lot of people adopted it. But it introduced some unforeseen complexities also, rather than giving more advantages. But those unforeseen situations you should be able to handle through configuration properly. Otherwise, Hibernate is more headache than what it solves the problem for you. Okay, so they are moving away from Hibernate as well, and going towards like a Spring JDBC or Spring Data kind of stuff. But still, Hibernate is there. But bunch of problems should be able to address it. It gives some advantages that we're going to talk about it in a little bit. Okay, it gives very good advantages. If you don't use it properly, um, it's a problem. And that's why people say anybody can use Hibernate, but who can make it fly is really important. That's why you need to know internals of Hibernate to use it in a commercial application. Okay, so here you saw service layer node. Okay, data layer returns. Where did you see the thing layer thing? I'm
And
just
procedural approach, after procedural approach.
okay, here.
Yeah,
No
down.
object model data access layer returns data transfer objects. Like,
No,
no, probably somewhere here.
this one. Yeah,
Okay,
object-oriented approach.
okay. Complex thin service layer, rich object model utilization, standard design pattern. Okay, okay. Yeah. So what I said, I just remember that. Like, okay, see here. Um, Persistence layer is actually doing retrieval. It is constructing the DTO, and just service layer is just using it like a communication driver. Okay, that way it is called yeah, lightweight. Previously, here um, here it is a little bit heavyweight because when it is talking to persistence layer, it has to do something to convert it into DTO and send it. And it has to read the DTO, do some other operations, and send it back to the presentation tier. Okay. So whereas here that headache is gone, like converting from DTO to domain object and domain object to DTO is gone. Okay. So this has all been taken care of. Even persistence layer is giving them domain object. Okay, like Hibernate. If you use Hibernate, student object is there, right? Student table. That student table is converted into student domain object. Okay, that student domain object is constructed by using the Hibernate mappings directly. Like all columns are treated as properties within a student object, and name of the student table is mapped to student object. So when you do like get student, it's going to give you student object directly. You need not have to do iteration through result sets, construct a student object, list of student objects, and return it. All that is being taken care by the persistence layer, and you just get the domain object out of it. So that's why all that headache is gone, like converting something to a domain DTO and sending across. Yeah. Okay. Then mixed approach. Object-oriented model can be basic to moderately complex. Simple model is just used as a data access. Model can take on business logic, common behavior for different service layer use cases and all that stuff. So previously in EJB2 and all that, um, like bunch of stuff like entity beans, like bean managed persistence and container managed persistence. You don't need to know about it right now, but like all this transaction management and all that stuff, if you want to take care of it, that is called bean managed persistence. Or if container is taking care of it for you, then it is called the container managed persistence. Like this is all pre EJB3. Okay, now we are in EJB3.x. Like if you look at Java E6 and all that, we came far away from that. Like 2005 to like 2003, 2004, 2005, people were like really scared to use Java EJBs, like and enterprise Java beans that we're going to talk about in our sessions after Hibernate. Okay, but that's because the complexity that it introduced. That's why once EJB3 came in, which made it lightweight, looking at Hibernate. Hibernate could do why Hibernate had to be like introduced because EJB was like really really complex. Okay, so that's why Hibernate has been introduced, which is like off the shelf, outside Java stack, and they were able to adapt to it so quickly and no cumbersome stuff. Um, that's why like when they initially used these entity beans, this BMP and CMP concept in EJB 2.x, it was like really complex. So mixed approach is something like that. Like you're going to use either bean managed persistence or container managed persistence and all that stuff. And that being said, what is BMP? This people may ask. What is BMP? Bean managed persistence. That means within your service code or within your DAO code, you're going to say like session.begin transaction and do some operations and session.commit transaction. If you do it yourself, that is called bean managed persistence. Or if you leave it to the container, okay, when to begin a transaction and when to close a transaction, then it is called container managed persistence. Okay. So object-oriented model can be basic to moderately complex application. But if you start adapting to mixed approach, maybe it can fly. Like simple model is just used as data access layer, and model can take on the business logic, like common behavior for different service layer use cases and all that stuff can be taken care by model as well, and uses advantage of both extremes, like both procedure oriented and object oriented, and difficult to remain consistent within the same application because it may change, right? Like if if the downstream DAO changes, it has to know, or if something on the service layer changes, it has to know. So that's why this hybrid approach may not fly, but there is one possibility to use all good things about both the approaches, which is called mixed approach. Okay, it depends on the situation that you want to use, but predominantly people may use object oriented approach. Okay, any questions so far? Are confused with the design approaches?
I don't get the mixed approach. And is a EJB like Hibernate?
Not like Hibernate. EJB was like dealing with all these on saving. Like if you think about EJB container, uh, say if you were to get some data from a remote application, okay, if you were to get some data from a remote application, it used to make it transparent. Like there are some things called stateless session bean and stateful session bean. We will talk about it in Java EE. But what that entity bean, to your answer, what that entity bean is all about is talking to the database and reading from database. Yes, in that aspect, it is similar to Hibernate, but it used to do bunch of other stuff than just reading and writing to the database. Like it used to have this container managed persistence, bean managed persistence, and you need to configure bunch of stuff before you start even using those and all that. Okay, so to your answer, in this context, yes, it is similar to Hibernate in terms of writing and reading to database, and it became it has to have like EJB jar.xml and all that you have to deal with a little bit complex than Hibernate. And the entity beans are not just POJOs, plain old Java objects. It used to have a bunch of other methods than just simple POJO. Okay. In our coming slides, we just briefly talk about traditional persistence. Here you will get a good handle of what EJB is all about. I can walk you through that. But to your answer, yeah. See here, if you look at, I think this diagram can explain you. Presentation tier, service tier, and JDBC tier. Okay, you need an application for Hibernate to run. or for JDBC to run, we didn't use any application server, right? Like we did not use anything like Tomcat or JBoss or WebLogic that we are going to discuss next week onwards after Hibernate. We did not use any of those. All we had
Mm.
was a database table, JDBC jar, and we used it, right?
Yes.
Uh, Here, if you want to use EJB, you need to have an application server. Presentation tier has to talk to a design pattern called session facade, which actually over the network manages. If you have like 1,000 requests, this is the guy that manages, okay, whether how many I need to send it to a server and all that stuff. Okay, it manages the network traffic and all that for you and sends it to the server, and that guy talks to the database persistence layer, converts an entity bean that talks to the database, and database gives another entity bean, and then we again convert it here. That needs an application server. That's why it is a little bit complex than simple stuff. And Hibernate looked at this approach of traditional persistence with JDBC, and they took to a new level, because to use Hibernate you don't need any of these stuff. Okay, but in terms of functionality, yeah, both are designed for the same, but one failed, other one succeeded in doing that. Okay.
Mm.
Hey Brinda, you can just follow from this slides, like you can look at the recording later for whatever stuff that you missed, but from here you can get the context like what we are talking about today. Like traditional approach, this we know, like presentation tier is nothing but some UI. If you're on Amazon website, say suppose you ordered something, it can hit a service layer, and service layer can talk to a database to actually create an order that you performed, right? So all that can be persisted or saved in the database. This is the traditional approach, and this is like pre-Java E5. This is the approach. This was the approach that used to be followed. Now we are in Java E6 and plus. So this approach is being removed totally, and uh, how it is being removed, and all that we are going to talk about it. And what is Hibernate? Why we are using Hibernate? You can just look at the recording later. Okay, fine. So JDBC overview. Like you guys know all this, right? Establish a connection, load the driver, and all that. You guys know it already, right? And close the connection, commit, and all that. This is all JDBC approach. Creating an account. You can take this also as an exercise and execute it. But EJB 2.x, what it used to do. EJB API provides ability to map an object model to the database tables. Okay, that means a student can be an entity bean that can be mapped to a database table, and handoff management of database connections, take care of relationship management, manage transactions, and all that stuff. Okay, so this is all good. Even if you look at Hibernate, why how we do all this? Okay, we do all this even with Hibernate, but see how it is being done in an EJB. And you need to have a home interface, a remote interface, a bean class that is like an implementation class, and you need to set up these XMLs, because the application server container knows anything that you do only through this XML. Okay, in the code, look up the EJB home, create an instance of EJB home interface. Like look at this interface, like home interface. Okay, we'll know more about it in entity stateless session main and all that. But because of this home interface, remote interface, like again it is like a duplication code. See here, like home interface extends home, and there is like a remote interface extends an EJB object. It has like debit, credit, first name, last name, and all that. And in a class, like this is an savings account bean, you will create EJB create and all these methods. And these are called callback methods: EJB post, EJB remove, EJB load. Like pre EJB 3.x, this is very important interview question. What are like important callback methods that you implement in an EJB? Okay, entity bean. Then you will give the implementation for all the methods of the remote interface. Then you map it here. Okay, like entity description is this, name of the EJB bean is this, home interface is this, remote interface is this, entity bean is this, okay, and each field name you're going to specify and all that stuff, okay. And once you did that, you're going to map it to a database using some lookup called JNDI, Java Native Directory Interface, and put it in the application server. That's how application server knows there is a uh, that's how application server knows there is a database like that, and these are the field names, and uh, these are the database field names, and these are the property field names. Then from a client code, like we created something called ejb test client.java. You get the initial context, you get an access to the home interface, which internally gets the like talks to the remote interface and gets the savings account home object. And then you create a home dot create, and you're going to pass all the objects. That means using the home interface, you got a handle of a savings account home. If you look back, what does the savings account home has? Savings account home has create, find by primary key, find by last name, right? So you pass all these methods to create. And what does remote interface has? It also has create, but I think it did not show it here. It also has create, like this one. Say for example, EJB create. Okay, so what happens is you invoke create method on the remote home interface. Internally, remote interface guy actually talks to entity bean, and it invokes a EJB create, because if you look at the ID on home interface, ID, first name, last name, balance, right? So internally, this EJB container maps the EJB bean, savings account bean, to the home interface. So that means in your test client class, in your test client class, you are creating a savings account bean. Then you are invoking methods of remote interface like john.credit, john.debit. That means home interface, like this is architecture, like in the container. Go back to the first slide where we were talking about this one. See here, uh, I think in the EJB there is one. Oh, didn't I show something called home interface, remote interface, and all that? Okay, let me actually quickly show something like that. Okay. Maybe with that you will understand. Okay, see here. Is it visible to you guys?
Yes.
Okay. So client, just now we saw a client, right? So EJB container, it has all the entity beans here, or it knows how to talk to the database. Okay. So what it used to do, client object invokes the home object. Home object internally creates the remote object and returns the remote object to the client. Okay. Then you can call all the methods that are available on the remote object. And this remote object knows how to talk to the entity bean. Okay, and that guy actually talks to the database and performs some operations and returns a remote object and sends back the response to the client. Okay, so we need to get the home object. Home object knows where the remote object is, and it gives us the remote object interface. And on top of it, you can invoke some methods. So it only the remote object talks to the entity bean. Nobody else knows anything about the entity bean outside remote object. Okay, that means it encapsulated all the communication between remote object and entity bean. Okay, client doesn't know anything, or anybody outside the EJB container knows anything about entity bean. Okay, making sense? It's not required for you guys, but I'm just showing you how it used to be. Okay.
Mm.
We'll talk about it in Java EE again, but just keep this in mind. Okay. Yeah. So let's go down. So that's how it used to be. Like, you got to deal with a bunch of these stuff, and then invoke, and then call home dot find by last name and all that stuff. Then you get a collection and all that, all these methods.
What's the
Where
use of having the home interface then?
home interface and remote interface, that's because remote, RMI, like remote method invocation. What is that? Is nothing but client side code and server side code. Okay, what home interface does is client knows only about the home interface. That means client side has the stub. Okay, and you got the object instance, and you invoke a method on the home interface in such a way uh, that, say suppose you are talking about getting a home interface, because you know only home interface on the client side. You invoke a method, actually it talks to remote interface, and it executes that method on the remote interface. That means, as the name suggests, um, okay, if you have a method called create, okay, in the EJB, um, you want to invoke that method, but that method is not in your as a client. If I'm accessing amazon.com, my client is nothing but amazon.com talking to some controller on the server side. Okay, but that server side is a web server. It doesn't know anything about the EJB. Okay, where does EJB reside? It resides in some other EJB container. Say for example, I'm giving a arbitrary example. That means it is distributed. It is not here anymore. It is somewhere else. Okay. Uh, but because of having this home interface and remote interface, you can invoke the home interface. Okay. You can invoke the home interface and execute methods on top of the home interface on your container, but they all execute on the remote machine. That means it is giving you a protocol. Okay, it is giving you a communication channel in such a way, if you execute anything on top of home interface, actually those get executed on the remote JVM. Okay, so think about it like you have two JVMs. Okay, anything that you execute on your own JVM, but actually they all execute on a different JVM. All it is doing is giving you a all it is doing is it is giving you a infrastructure that can help you talking to all the remote stuff. That's why name came from, like home is, anything about it, but home only knows how to invoke a remote guy. That remote guy can exist anywhere. Okay, is it making sense?
Yes, got it.
Yeah, in the same way, that concept, if you think about the same concept, web services. Okay, you must have heard about web services, right? Like most of the applications now has weather reporting. Say suppose, like if you go to any of the weather channel websites, they say like, okay, I need to put that weather reporting component on my application. I don't want to redo it again, right? All I want to do is I want to incorporate whatever widget that they are giving and put on my application. If they don't give a widget like a component that I can download and put it, or I can access a URL, they may give me a WSDL file. Okay, say for example, I want to communicate with them by passing a zip code always. Okay, give me a zip code in my application that I have. I will talk to weather channel weather.com and get the weather report that they have and display it on my web application. If this is the context that you have, we don't want to rewrite entire code, right? Because they did it, they know how to do all that stuff, they know where to do it, how to do it, and all that. They are like already predefined, but all we are doing is we are incorporating it on our application. So you don't have to rewrite an entire code. What they are going to do is they are going to give you an XML file called WSDL, Web Service Definition Language, and all you're going to do is you're going to generate your stubs. That means on the client side, you generate all the code that they have, and you're going to invoke that code. Internally, it knows how to communicate with the weather channel. It communicates and gives you back a response. So similar concept is applied there also. Like, because you asked this question, I just want to bring in that concept as well. When we are talking about web services, it will be easy for you. Okay. So all you need to do is get the WSDL, called Web Service Definition Language, generate the Java classes, and invoke methods on the client side. And it knows how to talk to the server on the remote. Like weather.com can exist anywhere in the world, but it knows how to talk to it. But all you're going to do is invoke methods on the classes that you have on your system. That's it. It goes and talks to them, gives you back a response, and you go forward. Okay. So similar concept has been applied, but not exactly. Stub is on the client side, skeleton is on the server side. This communication between stub and skeleton is taken care of by this remote interface and the home interface. Making sense?
Yes.
Yeah. If somebody says skeleton, it is on the server side. It's not on the client side. Okay. All these APIs are all given by some concept called remote method invocation. Java had that concept called RMI, remote method invocation. In Java EE stack, RMI is also one of the concepts. Okay. Now, that being said, let's move on towards traditional persistence versus Hibernate. So, what is this Hibernate doing? Persistence with Hibernate is presentation, business, persistence layer, and database. And this persistence layer has stuff called Hibernate, where it knows about domain objects, it knows how to cache things, and it knows how to talk to the database. Okay, that's where Hibernate comes into picture. It gave us not just these layers, it started introducing for us like domain objects also, and cache and everything. Okay, it's like we put it aside such that today we are using Hibernate, tomorrow we want to use iBatis, or top link, which is from Oracle. These are all various object relational mapping frameworks. We can use any of these. Like, just none of these layers change. Presentation, business, and persistence or data access change. Only thing that changes how you talk to database may change depending on the persistence provider. Okay, so that's how we made it like always component based. Okay, if I want to change this, how easily I can change, how easily I can accommodate a change, or how easily I can upgrade Hibernate to a newer version. So all this comes into picture when you are going towards a framework in your application. So if it is easy, we adapt to it. If it is not easy, we don't want to adapt to it, right? Yeah. Then let's move on. So Hibernate history, it started in 2001, and Gavin King, he has a book as well on this. He's one of the key developers in Hibernate, so his books are like probably famous, and it has more details. And he was part of JBoss also as a lead Hibernate developers. And then he was part of EJB 3.0 as well. When Sun Microsystems wants to adapt to JPA, he was part of that as well. Then for .NET and Hibernate is another stuff that they brought in. We don't want to know much about it. We are Java guys. Okay. Hibernate goals. When they started looking for Hibernate, what are the design goals that they had? Like, prevent leakage of concerns. That means domain model should only be concerned about modeling the business process, not persistence, transaction management, and authorization. All our service layer should deal with only business logic. Persistence, transaction management, and all should be taken care by somebody else. Okay. Flaws of EJB 2.x, like it is cumbersome and complex in EJB 2.x. So that's why they want to prevent that. Transparent and automated persistence. Complete separation of concerns between domain model object and persistent mechanism. That's why Hibernate is in the side. Okay. Persistent solutions does not involve writing SQL. We are Java developers, right? We don't want to write SQL queries. That's when we use these kind of frameworks. It translates into SQL queries. Like you just say session.create or session.save and give the name of an object. It internally generates an SQL for you. Okay. We'll see all that. You will appreciate the concept then. And metadata in the XML, like object relational mapping should provide human readable mapping format. If you looked at a EJB jar, it has like bunch of stuff, right? Not like that. It should be like really simple was their thought. Reduction in lines of code, like too many lines of code is bad because tough to maintain. Importance of domain object model, like why do we need to use the domain object model? um, the reason being, domain object model makes it easy for us. Like you guys saw, right? Object model here in our previous slides. You saw that, right? So importance of that, like domain object model. Yeah. It is easy, right? So that's the reason why they want to adapt to it, and they started doing some development towards domain object modeling. Okay, that's the motivation. Then why Hibernate? This should answer your questions. Okay, all this is are fine. Then impedance mismatch. What is impedance mismatch? Maybe most of the interviewers may ask you this question. Pay much attention. Impedance mismatch is, if you look at directly in the dictionary, impedance mismatch means object oriented is developed for oops, like polymorphism, inheritance, abstraction, encapsulation, all that stuff. Relational database is used for different purpose, like normalization, persistence into the database, record locking, transaction management, and all that stuff. But these two are designed for two different approaches. Okay, this is object and this is like relational, and it is like a procedure oriented stuff. Okay, now so these two are designed for two different purposes, and it's always tough to manage. That's why object relational mapping came into existence. Anything that you do in object will be mapped directly onto relational database. Like if you create an object called student.java, we map it to student table. If you create a field name in the student object as ID, we're going to create a column name ID. Okay, so like that we map, and two different words which are designed for two different purposes, we bring it into one place called impedance mismatch. Okay, this impedance mismatch is nothing but these are designed for two different purposes. And now OR mapping will bridge the gap. Okay, will bridge the gap in between these two worlds. In between these two worlds, and why do we use Hibernate? Is to bridge the gap between two different worlds of object relational world and relational mapping, and that is what is called object relational mapping. So what is Hibernate? It is object relational mapping framework. What is Toplink? It is also object relational mapping framework from Oracle. And Hibernate is now taken over by JBoss. Okay. Then failure of EJB2.x is one reason why we want to use Hibernate, because entity beans were extremely slow and complex. That's why not many people adapted to it. And another approach is Java developers are not database developers. Reduce the need for developer to know fully understanding database design, SQL, or performance tuning. Increase portability across database vendors. Increase performance by deferring to experts. Increase performance by uh, who are these experts? That Hibernate framework developers are already experts. They dealt with all the performance problems, and they gave us the framework. So they must have thought about a bunch of other stuff than us, right? Writing efficient SQL statements, using Hibernate cache. Cache is nothing but uh, it's like a temporary storage. You don't want to hit database always. Hitting database always is a expensive operation. Okay, talking to database always is an expensive operation. So what do? We read once and put it in the cache. So when you fire a query next time on Hibernate, it looks up in the cache. If there is a result, it returns that result. Otherwise, it goes to the database and fetches that. So these kind of advantages are all available with Hibernate. Okay, and why not Hibernate? This is what I was talking about. Overkill for small number of tables. Complex legacy database schema, like you have a schema, old schema, which is really complex, like it has a lot of join relationships and all that, or heavy batch processing, like if your application had like a heavy batch processing, then don't use Hibernate. Advanced queries like more SQL control, because that's when Hibernate can bring in a lot of problems than solving a lot of problems. Free but tied to a third party, or complexity or scaling concerns. That means if you have like uh, billion users, all billion users cannot be in one database, right? They have to be scaled horizontally. Um, that means you want to have multiple nodes in of database, like 1 to 10,000 can be in one database node, 10,000 1 to 20,000 can be in one node. Okay, so when you fire a query, it goes to a shared server and identifies, oh, okay, you're talking about this user, so then this user's data is all in database one, and it goes there and fetches the data. When you fire another query, it goes to database 100 and it fires query and fetches the data. So that is what is called sharding. Okay, it's very important concept. Um, not many people know about it. So if you have this kind of infrastructure, Hibernate may not be a right thing to do. Okay, then who uses a Hibernate? Bunch of people use Hibernate. This is just some statistics there. Okay, how to install Hibernate? Go to hibernate.org and get the downloads. Okay, select the binary version. This is old slide, like it's not 3.3 now, it has like 4.4 or something. So download whichever one is the latest production version. Then once you download the distribution version, copy the hibernate.jar and distribution jars in the has required jars. You get all those, and also download slf4j. Okay, once you have all those, put it in the class path and you're good to use Hibernate. Okay, you're good to use Hibernate. This Oracle Express thing we don't need to do because we are using MySQL instance. Okay, so no need to do anything else. Just that if you have all those jar files, you are good to go. Okay, so so far are we good with why Hibernate? What is Hibernate, and why are we discussing Hibernate? Are you guys comfortable with that? Is that a yes?
Yes.
Okay, so fine. Now let's see what we are going to talk about. Okay, okay. So here I have bunch of Hibernate jars, just like how we discussed. Okay, and now look at it here. I have bunch of classes and all that. Forget about that for a moment. And here, so database type is JavaDB, and if I have a JavaDB, I have a database DAO class, which actually creates an account object and all that stuff. Okay, this is a derby thing, but I am going to convert it into our MySQL instance. Okay, let's. We all know how to create this one, right? We just need the MySQL.jar, right? And let's go configure our MySQL stuff. Oh, I thought we changed
Type
bunch of
4.
stuff. Yeah. Okay. So this is the one. So I'm just changing it to, if it is Java DB, I want to convert it into or MySQL stuff. Okay. MySQL database driver dot connection URL is MySQL, right? And localhost. And which port I have this on? I have this on
3306.
3306, which is the default port for. See how easily I can move from Derby to MySQL, right? So just change the configuration. Okay, change the configuration in here. Fine. So if you go to my test cases that I am looking at right now, okay, let's close this guy for a moment. Right. So all I'm going to look at is this one, right? Java DB, and these are like test cases. Test cases really help us in testing our code. Like right now in our organization, also we're moving towards not having a QA. We need QA engineers, not QA testers. Okay, so that's the reason why what we are trying to do is developer, when he writes a code, he is responsible for testing the code. Okay, so that means whatever code you write, you should be able to test. And all these are Maven projects. Okay, Maven projects have by default, like I can convert it into a Maven project. Okay, so forget about Maven for a moment. I don't want to confuse you guys. This is a Java project and this is a test case, which is done by using JUnit. Okay, just remember that for now. Now to execute this, what am I doing? I'm creating an account object. I'm setting some account type, creation date and all that stuff. I'm invoking my service class, get account service, and saying like create account. Okay, what does this get account service has? It is creating a account service object, right? It is just creating an account service object. That's all. It's not doing anything. Okay, and what is it doing? Account service object dot create account. When I say create account, it is calling DAO. Okay, DAO dot create account. And what does this create account guy does? It because that was an abstract class, somebody has to extend that abstract class, right? So let's see Java DBA account DAO. So it has a method called create account. Given a create account object, what is this guy doing? He's creating our prepared statement. He's doing all this commit and all that stuff and all this, right? So this is our traditional approach. See here, this is all our traditional approach. Create account. He's setting the values, getting the values and all this stuff, right? This is all our traditional approach. This is not what we wanted. We want to use hibernate approach, right? So this is our traditional approach. You know this approach already. Given an object, you construct a statement. It can be prepared statement or a create statement. You set the values of account type and balance and everything. Once you do execute, it is going to persist. And here, if it is auto commit off, when you say connection.commit, that's when it is writing to the database, right? You know this approach already. Let's see what Hibernate has to give us, right? So let's see what Hibernate is giving us. Same stuff, how you can do it in the Hibernate stuff. Let's see. So this is our test class, account service test class. What am I doing here? I'm saying Hibernate utils dot get session factory dot get current session. That's when a session is begin. session.begin transaction. This is the important class in Hibernate called this one. Get session factory is an important, not class, it's an interface. Okay, it's an important interface called interface which actually deals with creating a session and all that stuff. So it's very important interface. So you're going to get the session.begin transaction. That means you are beginning your transaction. Create the account object. Okay, instantiate the account object, set the values to the account object. All you're going to call is on the account service, you're going to call save or update account. This is a method that has been created by us, and account DAO actually invokes save or update account. And within this, what is it doing? It is getting the Hibernate session and it is invoking save or update. Okay, there is no implementation to that. It is internal to the framework. We are invoking save or update in a Hibernate framework. What does it do? It takes an account object and it saves it. That's all. It doesn't do anything else. Okay, you don't need to iterate through the result set. You don't need to create prepared statement. You don't need to do anything else. All you need to do is get the handle of the Hibernate session and invoke methods on it by passing the object, and it gets persisted. Okay, and it gets persisted. Then if you want to get something, okay, then if you want to get something, how are you going to do? Get the session and you're going to get criteria. What is the criteria? Account class. I want to get the account class. Then I want to create a criteria called account class, and then say criteria.list. It's going to give us the list of all the objects that are available in that table, all the list of values. It is as good as saying select star from account. Okay, if you just write these two methods, these two lines, you're good. You don't need to write all the result set, iterate through the result set the values to an object and return an object. You need not do that. Get the session and then you are going to get the list of accounts. Okay, how it knows all this, how it knows whether there is an account object exists, how it knows like which table to look at, which schema to look at, all that will be in configuration. So look at the configuration here. Okay, look at the configuration here. So hibernate config.xml, this is important. Here we are giving all our database properties. Okay, here we are giving all our database properties like driver. Hibernate uses the driver this, Hibernate uses the URL this, Hibernate uses the database properties. It has to use the dialect MySQL. Because we are using MySQL, I'm going to say MySQL dialect, and Hibernate is going to use like if I don't have this database, if I don't have this database available, the name of the database that I am using, okay, it's going to create that. That means Hibernate can create database schema as well, and it can create tables if they don't exist. Okay, how it knows what tables to create? By looking at these mapping tables. Okay, we are looking at account table, right? Go ahead and see account.hpm.xml. What is it going to do? Okay, this is my account object. Okay, in that account object, account id is mapped to account underscore id in my table. Okay, and creation date is mapped to creation date. Like that, each individual columns are being mapped to other one in the database table. See here, account.java. Look at account.java. In the account.java, all you have is account id, account type, creation date, and list of e-billers. Okay, that means it has like this as an object, and we are mapping each and every property within this object to a corresponding entry in the table. Are you guys with me or lost? Are you guys with me so far?
Yes.
Okay, let me actually close my Sorry about that. This is not responding. Okay. Okay. So let's open my MySQL workbench. Okay. So here is the thing. I have my local host. Okay. Let me close all my stuff. Okay. So look at this. This is the schema that I created before, but I will drop it for you guys. Okay. So look at this. I don't have something called lecture one, right? Let's see. Let's go back to our test case. What is it doing? It's creating the, like if you look at the first test case, I'll execute only one test case. Okay. Here, let's close our other test cases. Like I'm just commenting out. When you say comment out at the rate test, it's not going to execute that. Okay. Here, I'm creating a new account, setting the values, then saving it, right? Once it is been saved, I'm incrementing the counter, and this code is actually deleting that account that has been created. I'll not delete it for now because we want to see, right, how it is creating. Let's see. Okay. Debug as JUnit application, JUnit test, because it doesn't have main method here, if you see. Okay. JUnit will execute anything that is mapped with at the rate test annotation. Okay. Fine. Here, execute that. So when you say get session, see how much it is doing in the background. Okay, we had an exception somewhere. Okay, so we had some exceptions. What are those exceptions? Let's see. Unknown database lecture one. Okay, so it is creating tables, but it needs to know, it needs to have a database. Okay, it needs to have a database. It doesn't create the schema, it creates the table. If I said the schema also gets created, I mean, let me see if we can create actually schema as well. Schema cannot be created, right? Yeah. Let me just try one more time here. Don't create schema before creating a table. Okay, so we got to create the schema. So we want to create a schema on our own. See here. Let's see if we put it here. Maybe it does it. Let's see. I'm just giving this a try when I did not create a schema with this before. Okay, create schema if not exists. And what is the name of our schema? Lecture one. Okay, let's see if it does it. Otherwise, I'll just go ahead and create it on the SQL itself. Sorry about that. I don't know why it's console is cumbersome. Yeah, I did not create. Looks like. Yeah. Let me actually go ahead and create. Okay. So let's just deal with it. Okay. See, this time we don't see any exception. Exporting generated schema to the database. So it does bunch of stuff just by calling the get current session. See, it looks at hibernate config.xml and loads all the tables. It looks at it whether they exist or not. If doesn't exist, based on the configuration, it creates them and then returns the session. See here, create an object, account type, date, all this, and then account service. We are saying like save or update. We're just saying save. Okay, hibernate session dot close. And if you look at it, account ID, we did not set the account ID, but it got generated. Do you see that? Account ID is the primary key. We did not create it, but it got generated. And if we persist it, see here, once it has been executed, let's go to our database. Okay, so let's see the table. All these tables got created. We did not create those tables, right? All these tables got created. And if you look at the rows within this, it got created here. See, are you guys with me? Are you following?
Yes.
Yeah. So see how it made our life easier, right? You just define whatever is there in the table and where exactly is the schema. Everything else is taken care. Okay. If you execute the JDBC stuff and this one, you will really appreciate the concept, right? Are you guys getting what I'm saying? Or any questions? So if you want to delete something, okay, or if you want to fetch the results, okay, if you just want to fetch the results, this is what you're going to use. Get the hibernate session. So it's reading everything now. Okay. Begin the transaction, creating the criteria, and you're going to say accounts.list. See here, it generated a select query for us. Select this dot account ID, this dot this from account. Looking at the console, yeah, it is generating this SQL query because I put it here, display. Like if you see here, echo all executed SQL to std out, show SQL true, and I put format SQL to true. That's when you are going to see formatted SQL queries, like good format. Otherwise, it's a little cumbersome to read. But this actually shows the right values here. Okay, so that's how you can see like what are the queries that are getting executed. And once you see that, so we got the account object from the database. See here, uh, this is what get, right? Okay, so we got the list already, and now we are creating another one. Oh, okay, so we have the list. We know we have only criteria.list showed only one. Hey. We did not delete anything, right? Did we? So let's see why it
There
showed
is
only
only
one.
one account.
Yeah, let me see why it's showing. I'm expecting it to show only one. Previously, yeah, at least it should show that one, right? And it created another one. It created another one, and what did it do in the create? It could have saved another one, right? It should have saved another one, and after the commit, it should be there. And we are doing another copy. Make sure these are two separate instances, and then delete it. Okay, but it's not created at all. Where is it getting deleted? Right? Let's see if it should not have anything right now. Yeah, because it did not get created. Let me actually make sure everything is compiled properly one more time. Okay, I'm just wondering. Let me execute this one and also this one. Okay. Mm, oh, I have the build automatically. And why it is not working? Okay. So let me actually create this one first. Idea is we should have two objects, right? Let's see. Okay, create one is executing, which we saw before. Let it run. Okay. Um, Now we are at the get stage. Okay. Before that, let's execute it here. So it has the all the stuff that is required. Now, when you say get, create, create criteria, create dot get should give us, yeah, it gave us one, right? Already. This list has one object, which is right. And what is this create guy doing? Let's see here. Build an account is building another account. Fine. And then saving or updating it. So this should actually give us 2 in here, but it is not. You see what I'm saying? This save or update should give us another object. Okay. This save or update should create one more object, and it did not happen. Okay. I think yeah, this is where object instance account ID not equals this. It is saying return false, right? Then why is it not creating? Should be creating one. I don't know why it's not creating. Let's see what it is giving us as account ID. It is giving us, right? Um, do you know what is the problem in this?
Not committing.
Yeah, but we are committing it here after create, and we are closing it also. Okay, I'm not right. Let's see. Let me just execute this guy for now. Yeah, it is committing it. Uh, yeah, I was thinking it is not committed, but it's committing it here, and we are closing the session also. So that's when it has to spill out to the database. Create criteria gave us one object, no objects at all. Ah, no, it gave us, yeah, no objects at all. That's crazy. Database does not have anything. Ah, somebody is rolling it back. I'm just seeing who is rolling it back actually. Hmm. Okay. Let's see. Let's play close attention this time. We need an account to be created. Okay. Okay. Done. Let's see what this guy has to do next. So we got it. Now we read the data. It should show one at least now. Yeah. Good. And now create account. Okay. Let's see what happened. It did not write up. See, now it wrote. Second one. Okay. This was my expectation. Okay. Let's see. Now get the current session, new service, another copy of the account. Now this another copy again had two, okay, because we are just copying with the same account ID. And now, okay, we closed it. Then cleanup. What is this cleanup guy doing? Is it has to delete the second one. has to delete the second one. And let's see, with this commit execution, did it do the second one deletion? Yeah. Okay. Okay. So previously, what I was doing was I had. Hmm, let's see. Now I have only one record. Okay. Let's do the same test again. Right. Only get. I don't want create again because get is the only one we want to do. Maybe there is something called delete all the rows or something is there somewhere to, that's why it is dropping when we execute only this test case, looks like. Okay, has data. After that current session, do we have data or not? Let's see. See, that's the culprit. Why? Because it's rebuilding our schema. It is rebuilding our schema. Here we said DDL create, right? Create or also update. We don't want to override it, right? If it is there, we don't want to override it, right? Initially, if when you don't have it, you're good. But when you have it, you don't want to do it again, right? Let's see. It's rebuilding your schema by dropping and recreating. That's why, or either you can say update or you can comment this guy out also, because you don't want to rebuild it. You have everything that you need. Okay, so let's just create this guy. Where are my debug pointer thing? Wow. Okay, so it created everything that we need. Let's go ahead and execute this guy. Okay, so now we should see 2. Okay, we had 2. So it's going to delete 1. That's okay. But now my idea is if I comment it out, just execute get, it has to create second one and delete second. Okay, let's do that again. Okay, get the list. So you have only one. Create the second one. After commit, it has to create. Right? See this one. Yeah, this is what I was expecting. It will delete that one. Okay. Okay. So it created with an ID 3. The reason being we are deleting it. When we delete it, it keeps the old indexes as is. If you truncate it, then it is going to reset the primary key. Okay, that's why it is doing 2, 3, and all that. Um, it keeps incrementing. Any questions so far? So we saw create and delete. Any questions?
What is the session object doing? Session.
This session object, it is
Yeah.
actually doing bunch of stuff. It is maintaining the database connection, and it is maintaining the temporary cache also. Like if you see, it has the connection object. It has all the mappings related to database in terms of Hibernate memory. Like Hibernate memory object graph will be there, right? So anything that is modified in the database, it keeps on syncing back to Hibernate session. This temporary object graph, it keeps syncing asynchronously in the background with the database, current database state. Okay, and also knows about what are the objects that have been modified. Okay, what is the existing session, whether it is open or not. Um, how many objects are managed objects? How many objects are detached objects? That means um, managed object meaning if you modify that when the transaction is open here, if you modify that, it is automatically written back to the database. You need not explicitly call commit. Then, if it is an unmanaged object, that means it is a detached object. That means it is not associated to any session. Okay. If you pass an account object to this get method before calling get session, then it's a detached object. So it knows, it does a lot of things behind the scene, like it keeps track of database, it keeps track of connection to the database, it keeps track of what got updated and what got deleted, and all that stuff. When you are actually writing some query, it does it in the memory and writes to the database later when you call commit. Okay, that means this session factory dot get session is very important. It knows the entire schema. It knows the entire objects that are mapped to that schema. It knows all the modifications. It tracks all those modifications, and it tracks whether there are attached objects or detached objects. If there is attached object or managed object, it is going to write it to the database directly. If it is a detached object, you need to make it attached to write it to the database. Okay, so it does bunch of stuff, and it also maintains temporary cache. That means if you see like this create criteria, okay, if you execute it like 7 times or 10 times within this same thing, it's going to give the same result. It will not fire the database query directly because you already executed it and there is no other modification. So it will not do anything to the database. It will read it from the cache and spill it over, which is called first level cache. That means session, whatever operations that you do are all in the first level cache. Okay. Say if you have various transaction types in your database that are like lookup tables, that means these values doesn't change that often. Okay. When you want to say like but you want to maintain those in the database table, there is something called second level cache in Hibernate. If you invoke if you put some objects in that, it is going to fire query only once. In like you can set the time limit like okay, execute it in next 10 minutes, refresh it every 10 minutes. So that way within those 10 minutes it's not going to fire query to the database, it's going to read it from the cache. Okay, it is going to read it from the cache. And why it is called second level cache is because this session guy, once the session has been closed, he's gone. No more that cache exists. Within a session only, all that caching happens. Once you commit or close the session, it is gone. Like it started here and it ends here. After that, it doesn't know anything about in between operations. Scope of it is limited. Whereas second level cache is across sessions. That 10-minute time, if you set, across sessions also it's going to read the same data. So it does bunch of more stuff. Hibernate does bunch of more stuff than we it shows to us. Like what it is doing, you can see all that in the console based log. If you read it here, if you read it here, it is reading all the properties. It's reading all the mappings related to account or any mapping file, any HBM files that you have, right? Any Hibernate bean mapping files that you have. It is reading all those, constructing, mapping all the objects, configuring the session factory, mapping the collections if there are any, driver manager connection. So establishing the connection to the database, okay? And setting the pool size. Right now, we put connection pool size as only one. You can set how much ever you want. And auto commit mode is false. That means your auto commit, right? Directly writing to the database doesn't happen until you do a commit explicitly, okay? And then it fetches the database connection. It knows what how to generate the SQL queries by actually reading the dialect, okay? Then settings factory, like bunch of things like whether it has to be using joins, or it has to be using not using joins, batch mode is eligible or not. All these are defaults, but we could control them as well. Optimize the cache, structured second level cache entries, we did not put anything, so it is disabled. And then whenever you are so whenever you are actually, it finally built your session factory here. And whenever you are writing a query, it does the query. And whenever you are actually reading something, it does the read. Whenever you are writing something, it does the insert, okay? So all this is being done by session factory.get session. Does that answer your question?
Yeah. Can we have many transactions in one session?
uh, how many?
Multiple transactions in one
Multiple
session?
transactions, session.begin, session.commit. Yeah, I think you can. Let's see here. So same thing, right? You don't want to close this session, right?
Yeah.
Yeah, just that it is not optimized. Only that is a problem. Other than that, it's fine. You see what I'm saying? Your session will be open for too long. That's not good. But you can have it. Let's see. That being said, let's test it. Just that you don't want to close the transaction here, right? Hibernate utils. So this guy dot current session. We don't need to get the session again, right? Because we did not close it. Session dot begin. Okay. Okay. Committed the transaction. It's throwing an exception, I think. Let's see. Session is closed. Transaction.commit. Session.get transaction.commit. Should not close the transaction. Let's see. if this transaction is session with which it is associated, unless session is flush mode manual coordinates, indicates a problem committing the transaction. But it doesn't close it here, right? Transaction.commit. Commit this transaction. Begin is going to begin the transaction. Should not close. Let's see what we have in our Hibernate configuration. Nothing much, right? Context is thread. Hibernate's automatic session context management. Current session context class. So what this guy says is he has one property. Yeah. Here's the Hibernate session is bound to the current thread. Hence, when the transaction is committed, the session is closed to. Alternatively, you can use if you want to manage the session yourself. So let me see. I think this will do what we want. Current session is the current thread, so current thread would have been closed. Okay, yeah, this will help. See here. What is it? Even creating an object, it is not doing it. See, it's throwing an error here, right? Saver without active transaction. We did a begin transaction, right? We did a session.begin transaction without an active transaction. Why would it say that? Open session doesn't help. Ah, this one again is doing what? Active account.service, build account. Yeah, it should be fine. Oh, create account is doing what? Account service. This guy again does this. That's why the problem is, I think. But let's see. Let me just put this guy there. But it should do. It should take the same session. Okay, so create account. I'm just going to call this session dot. We have the session here, right? Why do we need to create the account here? So we got the create criteria, get this account. Okay, we want to create an account. So let's just do session dot save or update. And account object is where I am thinking, let's see, build account, save or update. Let me just do the build account on my own here, right? Just like that, I can say build account. Build account, session dot save or update account. Okay, so we got the values. Nobody committed it, so it should not be committed at all. Let's see. Our database has 2 records. Okay, good. Now I'm building it. So it is built. What is the account ID? 0. Okay. We say save. It saved it. There are only 2. Yeah. When I say commit, committed it. So we saved it. Saved one. Now I'm beginning it again. So here probably again it's going to say connection is out, because again that get had another session probably. Yeah. I know why it's failing again. Yeah, it's like it says like you cannot say current session anymore, but you can do it. What you're going to do is that get account, whatever it does, in here you got to say like you can no longer say current session. All your methods needs to be passing a session. Okay. So yeah, that's why it's not working, but I can just demonstrate that for now. Another copy. So we can just pass the account ID. Okay, so let's execute this. So it's committed. Begin another transaction. Get another copy. Yeah, you can do it. What is it complaining about? Oh, asset must have failed. Asset fail. Do you know why this asset fails? You should tell me why asset fail. I'm just thinking this is the reason why it failed. It's not anything else. Yeah, that's the issue. You can close it. Or actually, it should say like not this one. It should say session dot close because you're opening it directly. Okay, so you can have as many as you want. Any questions?
What is the disadvantage of opening session for a long time?
Yeah, because you will be having like multiple database connections, right? Opening like database connections for too long is not good because you're not leaving it for somebody else. Like idea of a connection pooling is you take the connection, use the connection, and leave the connection so somebody else can take it. So if one thread is taking too long and operating on a connection for too long, there is always a possibility that you may get connection timed out exceptions uh, like it depends on how database is managing the connections as well, how it is configured as well, and also thread starvation may happen, like bunch of threads may wait for database connections. So idea is take it, use it, close it, so leave it so others can again read the connection, do the operations. Like if you are doing multi-threaded application, then this may be a real problem. Basically, thread starvation is the answer to your question. Ideally, there is no need for two transactions in one method. Uh, it should all be in one transaction or none. That's how you should design probably. Like there's no need for two things to be in one transaction. Like two different transactions in the same method. I'm just thinking, can there be a case? Yeah, it depends on the business scenario, but idea is don't keep it too long. That's the idea. Okay, so now we saw create, delete, and stuff like that, right? Now let's see update. We saw create, select, and delete. Let's see update also, and then I'll leave it for you guys to practice it for today. So um, you can be ready for next week. Okay, fine. So let's see this this one. So this is getting the current session, creating the account, and then creating the account and updating the account type. Previously, the account type is what? Savings. So he's just updating it to checking account. Okay. So let's see whether it's getting written back to the database or not. So it inserted one more. So it inserted a savings account, and now we are updating the same guy to closing the session, getting the session back, begin the transaction, getting the same account from the database, and see, it is still savings. It did not update. You see that? It should be checking, right? It did not update. Why it did not update? Let's see. It created an object and you say type checking is a checking account. And when you say save or update, it should write it to the database and then commit. Okay, but it did not. What could happen? Let's see. Save or update. Be able to handle this for us. Okay, let's see it again. Can anybody tell me why it did not do it? So now the account type is modified to checking right here. See the account type of that object that we are passing to save or update. Go inside current session. This is checking that we are passing. Once you do the commit, it's still saving it as account type savings. Isn't that crazy? This create account already written it to the database. Okay. Create account already written it to the database. Here we are writing it again here in the same transaction. See, just inserted. That's all. The first step is only been done, not the second step. Update. Like create account, wrote it to the database, and we are done. But this is not been executed. Okay. So if you do it afterwards in this begin transaction, and if you do it here, okay, if you do it here, If you do it here, probably it will be. Let's see. So it inserted. Commit. And this is not a managed object anymore. Okay, that's another reason. You got to get and set it. That's when it is going to persist. But this will also not solve the problem yet. But see here, it did the update. Previously, we have never seen the update query, right? In our previous runs, let's see. See, it still did not do the update to the database. It ran the update query, but it did not do it to the database. Okay, fine. What I'm going to do is now get the account and then set it.
What's the problem with that?
It's not managed instance anymore. Like when you want to do some operations on the database, it has to be a managed operation, managed object. It's no longer a managed object. That's the reason it's always complaining. Though it is executing, it's not writing to the object graph. Let me see. Even I'm trying to figure out. So here in this session, I am associating it to the managed object. Like I'm associating it to the session. Like a new object that has been fetched from the database, and I'm updating and saving. Probably this should do it. Let's see. So it inserted with the saving still. Got the account back from the database. Set the this one. Did not write the update query. I don't see the update query still. Still it's the same. This is crazy. Let's look at the reason why it's not getting written is probably update is false. I was trying all different things. Once again, okay. Let's wait. Um, let's revert back whatever I did in here. This was our original stuff, right? This was our original stuff. You are creating an account using the same account and you're updating the account type, right? All this is good. And if you go back in here, this account type is not getting updated because of this one. Configuration didn't let us update. That's the only thing. Um, I'm like, why it is not working? Okay. So let's see here. Okay, so the update query fired even before it fired, you can say that. Now it is updated to checking. Okay, so the problem was in the configuration they did not let us update the account type. That's the reason it did not write, though you were modifying in the object, it was not writing to the database. But all I said was incorrect. Here it was creating the account. You're just modifying that account and re-updating it. No need of closing the session. It has to do it because it's all part of the same transaction. That's why transactions are meant for, like, within a transaction, everything is managed. I was like thinking why it's not doing it. Maybe it's not managed and all that. But no. So it is managed and it has to be persisted to the database. The reason it was not doing it is because of this guy being false.
It won't throw an error.
It won't throw an error. It won't throw. That's the problem. Like, you need to know the configuration. Otherwise, yeah, you'll not know. You think you are doing it, but yeah, this can be kind of considered as one of the problems with frameworks. You should know the framework properly. But the other one is right. This one here, uh, another account that get account type I set true. Like, probably I was demonstrating to somebody. That's why I put it this way. Otherwise, this assert condition doesn't make sense. Yeah, it will not throw any error because it is not attempting to write anything, right? So yeah, this kind of configuration may introduce effects that we don't want to. That's why we don't want to tweak in properties that we are not supposed to. Like here itself, when somebody is invoking set account type, we should throw an error. Like, if it is an update call or something, update is not allowed, something like that. It is just a demonstration of the feature, so just keep it in mind. If something your setting is not getting updated, go look at the configuration first. Okay, this should not throw error now because that assert was incorrect. Previously it was throwing that error because, yeah, this executed fine now. Okay. Any questions? Did you guys follow? Any other questions that you have?
No.
Yeah, you guys have to practice this. Before next session, make sure you execute this one. I'm going to upload this right now to you, like the executed one. So make sure you guys run it. It's lecture 3, and we can start 4 and 5 next week. But let's see if I have to do anything in here. Like, let's see. Okay. Simple Hibernate example. Let's see here. So what we are doing right now is creating the, you guys understood right now, right? So any application has a persistence object that is nothing but account.java that we had. And within Hibernate, we can have hibernate.properties or hibernate config XML. Either one of these is fine, but we went in the XML approach. And we have the database. So what we are doing here, define the domain model, like account model, e-biller, and all that in this current database schema. Set up your Hibernate configuration, like hibernate config.xml, and create domain object mapping files, like say account, if it is account, account.hbm.xml. Okay, make Hibernate aware of the mapping files. So your updated Hibernate config.xml with a list of mapping files, and there is an Hibernate util class that we have created that actually helps us in creating a session and updating a session. It is from the base framework, so we can just directly adapt to it, like get Hibernate session factory and all that. Okay, and then write your code like account owner, account, e-biller, e-bill, account transaction. So this is probably a application that we are dealing with. And right now we just saw account object, right? So account object, we created like a savings account, we updated a savings account, we deleted a savings account and all that. So this is one of the database models. So database model, we converted into classes in Java, like account.java, account transaction, e-bill, e-biller, and account model. So that means if you think about it, like one account can have one or more e-bills, like one to many. That's why in our account.java, we had a list of e-billers. If you see here, account.java, we have a list of collection of e-billers. Okay, list or collection, right? In the same way, like this can be 1 to 0 or many. Like an account can have one account transaction or many account transactions, and an account can have many account owners, like joint account owners and stuff like that. So this is the model that we are trying to address in Hibernate. So what we did here, we did Hibernate session factory. Like if you look at the Hibernate configuration file, if somebody asks you what is there in Hibernate configuration file, session factory, and we set all these properties. That's how when constructing session factory, it knows what are the tables to, what are the objects to look at, what are the properties of a connection and all that stuff. Okay. Then within session factory, you give the database class name, driver class name, URL, username, and password. These all go to the connection object, and what kind of dialect to use, whether it's Oracle or MySQL and all that stuff. Okay. And there are multiple ways to configure Hibernate, and at an application level, leverage multiple methods at once. Hibernate will look for and use configuration properties in the following order. Like if you have a properties file, it looks for a properties file. If it doesn't have that, it will look for hibernate.config.xml file. Programmatic configuration settings like session factory, we read the session factory and we set the schema. So if we either we can do it this way, or we can just say hibernate utils.get session factory. It is going to look it up from the class path directly. Either you give the XML file by putting it in somewhere else, or you can actually read it directly. Okay. Then you have the hibernate mapping.xml. It has, like if you look at one of the account.hvm.xml, right? So if you look at this, it has a class, it has ID, properties, okay? All this list, you're mapping it to database table, okay? Class name, you need to tell, okay, which class name and which table name it is mapping to, which field name, which column ID it is mapping to, okay? And type of the column, if you want to allow to update or not, what type of column it is, string, long, or all that stuff, okay? And then, so if you look at the account schema, it has to be something like this: account ID, account type, creation date, and all that. So mapping the file after the Java object. So that makes it easy to understand. And Hibernate ID generators. There are various ID generators. Native meaning this one. ID meaning primary key. If you look at this, account ID, okay. So either it can be primary key, auto increment. That's when we say native, it does that. Or when you say increment, you want to increment by 1, you can use an incrementer. Or UUID is like a hash code kind of stuff that you can use to individually identify unique IDs. Okay, so either you can do your own sequence generator and set it to Hibernate, or you can tell Hibernate to generate it on its own. And it has 3 different ones. Okay, I'm talking about it in here. Like if you look at the generator, you can say native, or you can say increment, or UUID. Okay, tweak with this. So Hibernate util um, is a utility class, convenient class to handle building and obtaining the Hibernate session factory. Recommended by, like use of this is recommended by Hibernate.org, which is the place where we download stuff from. Session factory is thread safe, so it's thread safe. That means multiple threads accessing the session factory is also fine. Okay, use to build Hibernate sessions. So Hibernate sessions are not thread safe, one per thread of execution. Okay, so we used session.save or update, session.get, session.delete. So the one important interview question people may ask is, what is the difference between session.save or update and session.save? Session.save is going to just save it. Session.save or update is either, if that record doesn't exist, it will save it, or if that record exists, it is going to update it. So that way, save or update is more friendly compared to save. So if you have to create an account using JDBC example, it has to be like really cumbersome, right? You got to write this much lines of code, approximately 37 lines of code. Okay. Whereas here we are going to just do 2 lines of code, right? Delete testing unit engine. Unit is an open source framework to perform testing against units of code. Unit testing meaning you're going to write a bit of code and you're going to test a bit of code. Okay. Okay. So this is how we used all our testing framework. Right? So why are we starting and ending transaction? In order to take the advantage of certain features in Hibernate, or recommends you to close your transaction as late as possible. For test cases, this means in tests themselves. Later, we'll discuss suggested ways of handling this within an application. To your question, you should see the output and console. We saw all these, right? So just play with it. You will see the sample, updating the balance, and you can write as many test cases as you want. Test delete, deleting some stuff. Okay. Update equals to false. See, this one they explicitly set it because we don't want to update it. Okay. So these are the SQL queries that get generated. For next week, we will talk about relationships. Like in SQL, we have joins and all that stuff, right? So how the relationships work and how Hibernate realizes those relationships and all that stuff. Okay. Any questions? Okay. So I'm going to upload these to our directory. If you guys already downloaded the videos, I'm going to delete all the core Java videos today. Okay. Did you guys download everything? Brinda, did you download as well? Did you? I did not hear. Yeah, to upload next stuff, I need to actually delete. So